Assalamualaikum and good day everyone. I hope you are all doing well. So we are now going to continue the second example for chapter 4, which is the Laplace transform on the circuit application. Okay, so for this question, there's actually a condition given, which is the current and also the initial current and also the initial voltage is actually 0. So reminder, okay, so actually this is only like a simple explanation, which the elaboration you can actually see in my chapter 1 Laplace transform circuit application part 1 video, where I will link it in the description box below. So this is actually just a recap so that you will have an idea when there's a zero initial condition stated. Okay, so basically, if the initial condition of voltage is stated, your inductor circuit will not have any voltage component, whereas for the if your current initial current is 0, your capacitor circuit, which is in the Laplace transform circuit, will not have also a current component. Alright, so basically a good practice for you to solve this type of question is, the first step is actually to transform the circuit into a Laplace transform circuit. But then a good practice is for you to write down all the components, where you transform each of the component individually first. For example, in here we have a resistor, capacitor, which one I haven't mentioned yet. Okay, all the components, and then transform it one by one into a Laplace transform representation. And then after that, once you have all, you just simply draw the circuit and just label it according to the one that you have transformed. Easier, okay? And moreover, the circuit is more simpler, or I can say is simpler, because of the condition. So again, if you want to have, if you don't really remember, or probably you don't really have the basic idea on that, you can refer to the video on the link below, okay? Alright, so basically after you have this circuit, what you have to do is actually to think on how actually you can produce a V naught S. Okay, because the question asks you to find V naught T, which means the final answer for your second step, which is solving the circuit. So finally, the final answer should be in V naught S before you can inverse transform it into a V naught T. Okay. Alright, so actually by observing to the circuit, actually you can use a theorem. Okay, actually I can say here, you can see that VC on the left, okay, the voltage on the left is actually the same with the voltage on the right. Okay, while you can see the left, there is one component which is the capacitor, while on the right, the component is actually the resistor and also the inductor. So basically, when we have VC equals to VRL, okay, I will show you the solution. Alright, so like my previous video, actually I just leave you guys in the middle of the video so that you can focus and can try to solve it by yourself. And I will try to include any explanation if needed, okay? Alright, so all the best to you. Okay, so for the next step, I'm using nodal analysis. Alright, so after you have found v naught s, what left is to convert it back to the time domain to obtain v naught t. So here is the process of me doing the inverse Laplace transform. Okay, so actually so basically the inverse Laplace transform you can obtain from the table of Laplace transform conversion itself. Alright, don't forget the UT guys, okay? Why it is one-sided a Laplace transform? Why is it we call it as one-sided? Well, because basically in transforming a time domain into a Laplace time domain, the integration that we did is from 0 to the positive infinity. Remember that, okay? Alright, so actually the video have finished, but you are all welcome to stay, okay? So what I'm trying to do here is just to write some notes on the the direct transformation from time domain to the transform to its Laplace transform. So for example, like UT, if you convert it, or I can say if you transform it into a Laplace representation, it will become 1 over s. And then the second one, okay, all of these are actually can be obtained from the transformation table of Laplace transform, where I really advise to any of you who did not have the table to probably you can obtain it online. As for my student, they are already have it. And yeah, the video is ending soon, so I would like to take this opportunity to say thank you and all the best to all of you. Assalamualaikum.